All right, hello and welcome. If you're deep in study mode for your AWS Solutions Architect exam, you already know that networking can be, well, a total nightmare. But what if I told you there's one service that can clean up even the messiest cloud networks? You guessed it. Today, we're cracking the code on the AWS Transit Gateway. Let's do this.
So here's our game plan. We're going to cover everything you need to know to just crush the Transit Gateway questions on your exam. We'll kick things off by understanding why this service even exists, then we'll dive into the nitty-gritty of how it works, see some real-world examples, and wrap up with the key facts you absolutely have to lock in. Okay, so let's start with the big question. Why? Why did AWS even need to build Transit Gateway? Well, it all boils down to what happens when you grow and how fast a perfectly clean network can turn into a complete mess. You know, as your company really starts using AWS, you're not just dealing with one or two VPCs. Nope, you've got tens, maybe even hundreds of them, one for each team, each environment, each app. So have you ever stopped to think, how in the world do you connect all of that? Before Transit Gateway came along, our main tool was something called VPC Peering. And look, that's totally fine if you're just connecting two VPCs. But what happens when you have 10 or 20? You suddenly have to create this tangled full mesh of connections, which looks a lot like that spaghetti diagram right there. Every single VPC needs a direct line to every other one. It's a management disaster that just does not scale. And that, right there, is the problem that Transit Gateway was born to solve. It's designed to take that complex mess and make it simple. Honestly, the best way to think about Transit Gateway is just as a central hub. It's like a cloud router. So instead of that crazy web of everyone talks to everyone, now everything just connects to this one central point. And just like that, you've got a classic hub-and-spoke model. It's all about bringing order to the chaos. Okay, so for your exam, this is the definition you need to tattoo on your brain. AWS Transit Gateway is a regional service that acts as a highly scalable cloud router. And its job? To pull together all the connectivity for not just your VPCs, but also your on-premise networks through VPN and Direct Connect. It's the one central point for everything. So how does this whole thing actually work? I mean, it sounds kind of like magic, right? Well, to really get it for the exam, you need to know its three main building blocks. First up, we've got attachments. Super simple. These are just the spokes in our hub-and-spoke model. An attachment is nothing more than the connection from one of your networks, whether it's a VPC or a VPN, into that central Transit Gateway hub. And wow, the flexibility here is just incredible. I mean, look at this list. You're not just attaching VPCs. You can hook up your corporate data centers with Direct Connect, your branch offices with a VPN. You can even attach security appliances like the AWS Network Firewall. You can even connect transit gateways to each other, which we'll get to in a sec. This is what makes it a real game changer. Okay, next up, route tables. So if the attachments are the spokes, then the route tables are the brains of the operation. They're the traffic cops. They control exactly where data is allowed to go. And here's the key part. You can have multiple route tables. This lets you do some really powerful network segmentation. For instance, you could have one route table for all your production VPCs and a totally separate one for dev, making sure they can never talk to each other. This is a massive concept for the exam, so pay attention to this one. And the final building block is inter-region peering. This is how you go global. It lets you link up two transit gateways and completely different AWS regions. And the major takeaway here, the thing you've got to remember, is that all that traffic is encrypted and travels over Amazon's private global backbone. It never, ever touches the scary public internet. That's a huge win for both security and performance. Okay, so we have our building blocks, right? Attachments, route tables, and peering. Let's put these pieces together and look at some of the real-world architectures you are definitely going to see on the exam. When you combine all these components, you can build a truly global network. This shot from the AWS console shows a real-world setup connecting VPCs, offices, and data centers from all over the world into one single unified network. And it's all managed from that one central transit gateway. Pretty cool, huh? Now, a super common scenario you'll see on the exam is this idea of a centralized inspection VPC. The whole point here is to force all your network traffic, or at least certain kinds of it, through a single VPC that has security tools like the AWS Network Firewall to check everything out before it goes on to its final destination. The flow is actually pretty straightforward. So a packet of data leaves a regular VPC and hits the transit gateway. The route table says, whoa, hold on, you got to go to the inspection VPC first. The firewall in that VPC does its thing, and if the traffic is legit, it sends it back to the transit gateway, which then finally sends it where it was originally trying to go. Now, for this whole inspection thing to work, there is one setting that is absolutely positively critical for the exam. This is the gotcha question right here. It's called Appliance Mode. Think about it. A stateful firewall needs to see both the request and the reply to know what's going on. Without Appliance Mode, the request might go through a firewall in, say, Availability Zone A, but the reply could come back through a different one in AZB. The firewall loses context, the connection breaks, and everything fails. So you have to enable Appliance Mode on the inspection VPC attachment to stop this asymmetric routing. You will see this on the exam. Remember it. All right, let's talk about the details that love to pop up as exam questions. You know, the fine print, pricing, and some of the specific feature limitations you gotta know about. The pricing model is really important to get. It's got two main parts. First, you pay a small fee every hour for every single attachment you have hooked up. Second, you pay a data processing fee for every gigabyte of data that flows into the transit gateway. So it's pretty simple. You pay for the connections, and you pay for the data that runs through them. Transit Gateway also supports a feature called multicast, but it comes with some very specific and very testable limitations. These are perfect gotcha questions. For example, multicast doesn't work over direct connect, VPNs, or peering connections, period. Any fragmented packets, they just get dropped. And this is a big one. You have to turn on multicast support when you create the transit gateway. You can't just flip a switch and add it later. These are exactly the kinds of details you want to file away for exam day. Whew, we have covered a lot of ground. So let's just boil it all down to the absolute must-know takeaways for your certification. Okay, brain dump time. If you only remember 5 things for your exam, make it these 5. Number 1, Transit Gateway is your hub-and-spoke cloud router. It simplifies everything. 2, you use route tables to segment and isolate your networks. 3, for that centralized security inspection pattern, you absolutely need Appliance Mode. 4, Inter-region peering gives you a private global network on the AWS backbone. And 5, you pay for attachments per hour and data processing per gigabyte. Got it? Good. And that is a wrap on the AWS Transit Gateway. It is a truly fundamental service for building networks on AWS that are scalable, secure, and actually manageable. So now you've got the building blocks. The only question left is what awesome architecture are you going to design first? Good luck with your studies, and I'll see you in the next one.